So what we did in the introduction here is said, if I have log 2 of 6, and I don't have that log base 2 button on my calculator, how could I solve it? Well, I could let x equal it, change it to exponential form, which I have here in the blue, and then if you take the log of both sides, that lets you bring that exponent out in front, and then you could solve. And this is something called the change of base theorem. It's up on the wall. It's not on your formula sheet. And the change of base theorem, and if you could write this underneath, this would be good. I color-coded it because what's really cool about the change of base theorem is that the orange part, the A, is only on one side. So normally with the formula, you have like things on both sides that correspond to each other. You can take log b of x and you can change it to any base you want. The A gives you options. You can make your A's 3's. You can make them 10's, which helps with the calculator. When we did ours with 10. But can you see in this example that I had done before, I could have decided to take log base 5 of both sides. And had I decided to take log base 5 of both sides, this would still have a 5, this would still have a 5, and there would still be a 5 here and a 5 there. And it would still be right, but if your calculator didn't let you do any bases other than 10, this would be useless. Because you'd be like, oh great, now I have 2 things I can't take into my calculator. So it made sense for us not to put a 5 there, just a 10, because we're allowed to use that. So the change of base theorem, I color-coded it here because it lets you choose anything. So for example, if you had log 3 of 7, you could pick a 10. I'll write it in red, but you don't have to write the 10, right? When you write log without writing anything, there's an invisible 10 there. And that would be helpful because you could type that quickly into your calculator. You could also choose a base of e. Remember the number e we learned? 2.71828, 1828, blah, 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 blah. That's the ln button on your calculator. So on my calculator, I'm going to pull it up here so that you can see. On my calculator, I have the fancy log button. Oops. Oh man, struggling here. There we go. I have the fancy log button, so I can type in log base 3 of 7. Yay, and get the answer. But I could also type log 7 divided by log 3. And I can also type natural log of 7 divided by natural log of 3. And because of the change of base theorem, these are all exactly the same numbers. And all scientific calculators will have the log button and the natural log button. So when you get to your exam, if you don't have a graphing calculator, you would need to be able to do this. So here is a question we're going to do as a warm-up. Again, you can keep adding this on page 401. Let's combine this as a single logarithm. And the number one thing I see students making mistakes with is the change of base theorem and the log law that's dividing. So take a look up over here on the board. Okay? The log law that's dividing is when you're dividing inside of a logarithm, and it's on the simplified or the left-hand side. And the change of base theorem has a log divided by a log. That's different. A log divided by a log is different than dividing inside of a logarithm. So the number one mistake I see here is students writing this as log 7 minus log 3. But instead, we can take that right-hand side of the change of base theorem and say, I can rewrite this as log 3 of 7. And it's right above, right? We have that. We can see working easier to work left to right, but now we're working from right back to left. And then if the bases are the same and you're adding, we could combine those together to get log 3 of 35. So let's go to example 1. So they want us to write the related exponential expression and then approximate each. And here, this would be a calculator question. So if you let x equal log 5 of 50, the related exponential equation would be the base is 5, the exponent is x is 50. And then you could either do the following. You could use your change of base theorem. And say log 5 of 50 is the same as log 50 over log 5. Or you could take the log, because what's going to happen is that you're going to look at this and say, oh, using the change of base theorem is easier because you just write out the answer. That's true. But on the exam, if you don't have that formula, sometimes what happens when you don't have a formula? You don't remember it. Has that ever happened to you? You have something that you're supposed to know on a test and all of a sudden you don't remember it? Well, if you don't remember it, you can take the equation and take the log of both sides. And then that would allow you to use an exponent law, and I can bring this x out in front. That gives me x log 5 equals log 50. And then I can divide, and I get log 50 over log 5, the same as I would have using the change of base theorem. But there's a possibility you forget something. So then you would have to go back to the basics of just using your log laws. Either way, if we want this to the nearest thousandth, we can now type in log 50 divided by log 5, and we get 2.431. And we could do the same thing for part B. I'm going to save us some time. And just use the change of base theorem. And you could type that into your calculator as well. Questions you can circle for this one.